High in the Peruvian Andes, more than 11,000 feet above sea level, stands one of the greatest engineering mysteries ever created. Overlooking the ancient city of Cusco, once the heart of the Inca Empire, lies the extraordinary fortress known as Sacsayhuaman. For centuries, this massive stone complex has challenged historians, archaeologists, and structural engineers alike. Its enormous defensive walls stretch across the hillside in three gigantic zigzag terraces spanning nearly 400 meters, forming a monument unlike anything else in the ancient Americas. What makes Sacsayhuaman truly remarkable isn't just its size, it's the stones themselves. Instead of ordinary rectangular blocks, the walls are built from gigantic polygonal stones, some featuring more than a dozen perfectly cut sides. Each block locks into the next with astonishing precision, leaving gaps so small that even the thinnest blade can barely fit between them. The scale is equally astonishing. Many of these stones weigh well over 100 tons, while some approach 200 tons. Somehow, ancient builders extracted these enormous blocks, transported them across rugged mountain terrain, shaped them with incredible accuracy, and assembled them into walls that have survived hundreds of years of earthquakes and human conflict. For decades, the accepted explanation was straightforward. Historians believed that Inca craftsmen achieved this masterpiece using simple bronze tools, stone hammers, ropes, and an immense workforce over many years. Their remarkable craftsmanship was considered enough to explain every detail. But recent discoveries have reopened the debate. Using advanced 3D laser scanning technology, researchers began digitally mapping not only the visible surfaces of the walls, but also the hidden contact points where the massive stones meet inside the structure. These invisible joints had remained concealed ever since the fortress was built. The results surprised even the researchers. The scans revealed that the hidden interior surfaces are carved with the same extraordinary precision as the visible exterior faces. These were not roughly shaped blocks forced together and stabilized with filler stones. Instead, every hidden surface was carefully engineered to match its neighboring stone with incredible accuracy, even though no one would ever see those surfaces once construction was complete. This finding raises a difficult question. If these hidden joints served no decorative purpose and would remain permanently invisible, why spend so much time shaping them so perfectly? That discovery has placed Sacsayhuaman back at the center of one of archaeology's most fascinating engineering mysteries. The fortress still stands today, its massive walls as stable as ever, while modern researchers continue searching for answers hidden inside stones that have remained locked together for centuries. Before exploring what these laser scans may reveal about ancient construction techniques, we first need to understand why the arrival of the Spanish conquistadors in 1533 left them completely stunned. Having already witnessed some of the greatest cities of the New World, they believed they had seen everything, until they stood before the colossal walls of Sacsayhuaman. The chronicler Pedro Chiesa de Leon, writing in the mid-16th century, described walls so massive and so precisely fitted, music, that they seemed beyond human capability. The Spanish soldiers who had just conquered an empire found themselves questioning whether the walls they were looking at could have been built by ordinary people. Some attributed the construction to demons. Others believed the builders must have possessed knowledge that had been lost, techniques so advanced that even the Inca themselves, at the height of their power, could not fully explain how their ancestors had accomplished what stood before them. The walls were that impressive. They remain that impressive. Sacsayhuaman sits on a steep hillside approximately 2 kilometers north of central Cusco. The complex covers an area of approximately 3,000 hectares. Music, though the most famous features are the 3 parallel terrace walls that form the northern defensive perimeter. Music. The walls are built in a distinctive zigzag pattern, not a decorative choice, but a military one. The angled walls created multiple fields of fire. Defenders positioned along the bends of the zigzag could attack enemies from multiple directions simultaneously. An attacking force advancing toward one section of the wall would be exposed to flanking fire from the sections on either side. The design was strategically sophisticated, but the strategic sophistication is not what has puzzled engineers for 5 centuries. The stones are. The construction technique used at Sacsayhuaman is called polygonal masonry, sometimes called cyclopean masonry, a term that references the ancient Greek belief that only the Cyclopes, the one-eyed giants of mythology, could have moved stones of such size. Unlike standard ashlar masonry, which uses rectangular blocks stacked in regular courses, polygonal masonry uses irregular multi-sided stones, music, fitted together like a 3-dimensional jigsaw puzzle. Each stone is unique. Each stone has multiple faces, some with as many as 12 distinct surfaces that must match precisely with the stones surrounding it. The joints between stones are not filled with mortar. There is no binding agent. Music. The stones are held in place solely by their own weight and by the precision of their fit. And that fit is extraordinary. The joints are so tight that the proverbial razor blade cannot pass between them. In many cases, even a piece of paper cannot be inserted into the seam. The stones appear music almost fused, as if they had grown together rather than been placed together. This precision has implications. Polygonal masonry is inherently earthquake-resistant. Music. When seismic forces shake a wall built of rectangular blocks with mortar joints, the stress concentrates along the horizontal and vertical lines of the joints. The wall cracks along predictable patterns and sections collapse. When seismic forces shake a polygonal wall, the stress music disperses across the irregular joint surfaces. The stones can shift slightly during the earthquake and then settle back into position. The wall flexes rather than fractures. Cusco sits in one of the most seismically active regions of South America. The city has been struck by major earthquakes repeatedly over the past 5 centuries. Music in 1650, in 1950, and in countless smaller events. Spanish colonial buildings have been damaged and destroyed. Churches have collapsed. Modern structures have cracked. The ancient walls of Sacsayhuaman have survived. They have survived because they were built with an understanding of seismic engineering that seems almost modern, an understanding that the conventional explanation of the construction process cannot easily account for. The conventional explanation, music, goes like this. Inca workers quarried stones from sites several kilometers away. Music. They transported the stones using ropes, rollers, ramps, and human labor. Thousands of workers pulling and pushing the massive blocks across mountain terrain. At the construction site, the stones were shaped using bronze tools and stone hammers. Workers would lift a stone, place it against its neighbors, identify the high points where the fit was imperfect, lower the stone, chip away the high points, and repeat the process until the fit was achieved. The process was called trial fitting. It was slow, it was laborious, it required immense patience and coordination, but it was, according to the conventional explanation, possible. The 3D scanning data has complicated this explanation. The scanning technology used at Sacsayhuaman works by projecting laser beams at the stone surfaces and measuring the time required for each beam to return. The technique can capture surface geometry with sub-millimeter accuracy, creating music 3-dimensional models that reveal details invisible to the naked eye. When applied to the exterior surfaces of the walls, the scans confirmed what visual inspection had long suggested. The fits are extraordinarily precise, with tolerances that would be impressive even with modern equipment. But the scans also captured data from the joints themselves, from the narrow gaps where stone meets stone, from the contact surfaces that have been pressed together for centuries. The interior surfaces of the joints are not rough. This was the first surprise. If the stones had been fitted using trial and error methods, lifting, testing, chipping, and repeating, The interior surfaces should show evidence of that process. There should be rough areas where the fit was good enough, but not perfect. There should be variation in the quality of the fit from exterior to interior. There is not. The interior contact surfaces are shaped with the same precision as the exterior surfaces. The fit is consistent throughout the depth of the joint. The stones were carved to match each other completely, not just on the visible faces, but on faces that would never be seen once the wall was assembled. This suggests that the builders knew, before placing each stone, exactly what shape it needed to be. They did not trial fit. They did not approximate. They carved each stone to a precise specification and then placed it with confidence that the fit would be correct. This implies measurement and planning capabilities, that the conventional model does not include. The second surprise was the complexity of the interior joint geometry. Polygonal masonry requires that each stone fit multiple neighbors, not just the stone below and the stone above, but the stones on either side and, in many cases, stones behind. The joints are three-dimensional puzzles with multiple interlocking surfaces. The scan data revealed that these three-dimensional fits are precisely maintained throughout the interior of the wall. The stones do not merely touch at their exterior edges. They interlock in complex geometric patterns that distribute weight and resist displacement in multiple directions. This is not simple stacking. This is engineered interlocking. The kind of design that would require either sophisticated modeling of the entire wall section before construction began, or capabilities for shaping stone that we do not currently understand. The third surprise was the surface texture of the interior joints. When stone is shaped using hammers and chisels, even stone hammers and bronze chisels, the process leaves characteristic marks. The surface shows the pattern of blows. The geometry reflects the limitations of the tool. The interior joint surfaces at Sacsayhuaman do not show the expected tool marks. Some surfaces appear almost polished. Others show a smoothness that is difficult to reconcile with percussion-based shaping techniques. The texture is consistent with removal of material by methods other than hammering. Though what those methods might have been, remains unclear. This does not prove that unknown tools were used, but it raises questions that the conventional explanation does not answer. The transportation problem compounds the mystery. The stones at Sacsayhuaman were quarried from multiple sites. Some came from locations several kilometers away. Some came from quarries at significantly different elevations, requiring the stones to be moved uphill. The largest stones weigh over 100 tons. Moving a 100-ton stone using ropes and human labor is not impossible. Historical experiments have demonstrated that large stones can be moved by coordinated teams using sledges, rollers, and inclined planes. But moving a 100-ton stone across mountain terrain, up and down slopes, across rivers and ravines, and then placing it with sub-millimeter precision into a predetermined position in a complex three-dimensional puzzle, this is a different challenge. The conventional explanation requires that each stone was transported, positioned, tested, removed, modified, repositioned, tested again, and adjusted repeatedly until the fit was achieved. The scan data suggests something different. The scan data suggests that each stone was shaped to its final form before placement. The builders knew exactly what shape each stone needed to be and carved it accordingly, then transported it to its position and placed it correctly on the first attempt. This implies either extraordinary measurement capabilities, or a relationship with stone that we do not currently understand. The question of who built Sacsayhuaman, is more complicated than it appears. The site is universally attributed to the Inca Empire. The Inca themselves, according to some Spanish chroniclers, were not entirely certain about the origins of the oldest megalithic constructions in their territory. When the Spanish asked about the builders of the Great Stone Walls, some Inca traditions pointed to earlier peoples, to beings from before the current age, two ancestors, music, whose capabilities exceeded those of the contemporary empire. The Inca certainly used Sacsayhuaman. They certainly maintained it. They may have expanded and modified it, but whether they built the original megalithic core, the massive polygonal walls that have survived every earthquake and confounded every engineer, is a question the historical sources do not definitively answer. The possibility exists that the Inca inherited these walls. The possibility exists, that the construction techniques visible at Sacsayhuaman belong to an older tradition. A tradition that was already ancient when the Inca Empire rose to power. A tradition whose methods were no longer fully understood even by those who maintained the structures. This is speculation, but it is speculation that the three-dimensional scanning data does not contradict. If anything, the precision revealed by the scans makes the mystery more acute. The fits are too good. The interior joints are too precise. The surface textures are too smooth. The three-dimensional interlocking is too complex. Something does not add up. The earthquake resistance of Sacsayhuaman is not merely impressive. It is instructive. The 1950 earthquake that struck Cusco was devastating. It killed over 80 people, injured thousands more, and damaged or destroyed countless buildings throughout the city. The colonial-era cathedral in Cusco's Plaza de Armas was severely damaged. Spanish-era churches and government buildings cracked and crumbled. The pre-Columbian walls survived, not just at Sacsayhuaman, but throughout Cusco, in the foundations of colonial buildings, in the walls of streets and plazas, wherever the original megalithic construction remained intact. The pattern was consistent. The older the wall, the better it survived. The more primitive, the construction, the more advanced its earthquake performance. Modern seismic engineers have studied this phenomenon. They have analyzed the geometry of the polygonal joints. They have modeled the stress distribution under earthquake loading. They have concluded that the ancient builders understood principles, of seismic engineering that Western science did not formalize until the 20th century. How did they understand this? How did builders working with bronze and stone develop construction techniques that outperform modern concrete and steel in seismic environments? The conventional answer is trial and error, that over centuries of construction in an earthquake-prone region, the builders gradually refined their techniques until they achieved optimal performance. This is plausible, but it does, not explain the interior joints. Trial and error operates on what can be observed. Builders try something, observe the results, and adjust accordingly. The interior joint surfaces cannot be observed once the wall is assembled. There is no feedback mechanism. There is no way to know whether the interior fit is good or bad. Once the stone is in place. And yet, the interior fits are perfect. This suggests that the builders knew what they were doing, that they understood the principles underlying the construction, not just the practical techniques that produced visible results. It suggests engineering knowledge, not just engineering skill. The difference matters. Skill can be developed through practice. Knowledge requires understanding. The interior joints suggest understanding, an understanding of stress distribution, of geometric interlocking, of material behavior under load. Where did this understanding come from? The 3D scanning technology that revealed the interior joints, is not the end of the investigation. It is the beginning. The scans have raised questions that conventional archaeology cannot currently answer. The data shows features that the conventional toolkit cannot easily produce. The precision documented by the lasers, exceeds what trial fitting methods would be expected to achieve. The next phase of research will require additional scanning, not just of Sacsayhuaman, but of megalithic sites throughout the Andes. The polygonal masonry at Cusco, is not unique. Similar techniques appear at Ollantaytambo, Machu Picchu, Music, and sites scattered across what was once Inca territory. Comparative analysis may reveal patterns. If the precision documented at Sacsayhuaman appears consistently across multiple sites, it suggests a standardized technique, a method that was taught and transmitted across generations, a tradition that maintained its capabilities over time. If the precision varies, if some sites show the expected tool marks and trial-fitting evidence while others do not, it suggests that multiple traditions were at work, that some builders had capabilities that others did not. Either finding would reshape understanding of ancient Andean construction. The laser scans have also opened the possibility of virtual reconstruction. If the geometry of each stone can be precisely captured and if the joint surfaces can be accurately modeled, it becomes possible to simulate the construction process, to explore computationally how the stones might have been shaped, in what order they might have been placed, and what methods might have produced the observed results. Bilkul. नीचे मैंने इस हिस्से को completely rewritten, documentary style और original narration flow के साथ लिखा है. ये सिर्फ लफ्ज़ों की तब्दीली नहीं, बल्कि स्ट्रक्चर और प्रेजेंटेशन भी नहीं है, जिसे ये ज़्यादा ओरिजिनल फील देता है. The laser scanning project is still ongoing, but its early findings have already begun reshaping how experts think about the construction of Sacsayhuaman. One conclusion has become increasingly difficult to ignore. These enormous stones could not have been placed randomly. Their complex shapes locked together so precisely that the order of construction appears to have been carefully controlled. Move one block out of sequence, and the entire arrangement would fail to fit. That means the builders likely knew the final design before the first stone was ever set in place. Whether that knowledge came from detailed planning, physical models, or methods that have since been lost remains unknown. What is clear, however, is that constructing these walls required far more organization than previously believed. Every block had to be carved with its neighboring stones already in mind, suggesting a level of planning that continues to surprise modern engineers. For more than 5 centuries, these massive walls have stood watch over Cusco. They have survived powerful earthquakes that reduced nearby buildings to rubble. They endured the Spanish conquest, centuries of abandonment, and even the removal of many upper stones, which were reused to build colonial structures throughout the city below. Yet the foundation remained untouched. The lower megalithic blocks were simply too massive to transport, too deeply embedded in the mountainside to destroy, and too difficult to reshape for other purposes. As a result, the core of Sacsayhuaman survived while much of the original complex disappeared. Today, modern technology allows researchers to study these ancient stones in ways that were impossible only a few decades ago. Using highly detailed 3-dimensional laser scans, scientists have mapped not only the visible surfaces but also the hidden contact points buried deep inside the walls. These invisible joints have remained sealed since the day construction was completed hundreds of years ago. The results have raised even more questions. Instead of finding rough interior surfaces, researchers discovered that the hidden sections were carved with astonishing accuracy. The precision extends far beyond what anyone standing outside the wall could ever observe. If these unseen surfaces were never meant to be visible, why invest so much effort in shaping them so perfectly? That question challenges one of the most widely accepted explanations of Inca engineering. Every new scan suggests that the builders possessed construction techniques far more advanced than previously imagined. Their understanding of stoneworking, structural balance, and earthquake resistance appears to have been extraordinarily sophisticated. The evidence is still there. It exists in the immense weight of each stone, in the flawless geometry of every joint, and in a design that has resisted nature's most destructive forces for centuries. Sacsayhuaman was far more than a military fortress. It was a masterpiece of engineering, a monumental display of knowledge and craftsmanship that still pushes the limits of modern understanding. Even after hundreds of years of research, many of its greatest secrets remain hidden within the walls themselves. As researchers continue analyzing the laser scanning data, new details continue to emerge. Each discovery challenges long-held assumptions and reveals just how much remains unknown about ancient construction. When the Spanish first encountered these walls, many believed no ordinary humans could have built them. Today, engineers reach a different conclusion, but one that is equally remarkable. The fortress is undeniably real, yet its extraordinary precision remains difficult to explain using conventional theories alone. Perhaps the greatest mystery is not that these walls exist. It is that every hidden surface, every invisible joint, and every perfectly carved connection suggests the builders possessed knowledge that has not survived into the modern world. The stones themselves remain silent. But the data collected from within them tells a remarkable story, one that suggests Sacsayhuaman is even more extraordinary than anyone imagined, not only on the outside, but deep within its hidden structure.